Session is actually going to focus on some key insights that has been taken from a study. The study is basically done to understand this EEG dataset and how this EEG dataset would be helpful to form or create a machine learning model, and how that would be helping us to detect or predict seizures. So starting with EEG, so it's an method, electroencephalography is a method which help us to understand brain's activity. So there's a device that we put on our scalp, and that detects some signals from the brain, and that signals help us to understand that which brain part is getting activated in which context. So this study actually focused upon this combination, that how EEG dataset can be used to in forming up a machine learning model, and how accurate that model will be in detecting or predicting seizures. So there's a problem that the data set which was publicly available, that has been used in this study, was not so standardized. There was the lack of standardizability there. So that is one of the challenge, because when they took the data, so the case of seizure in that complete data set was less than 1%. So when there's a less than 1% of seizure patient, so it's very difficult for ML model to get some pattern or understand some common pattern that is basically happening in seizure. Also, second challenge was noise, because EEG method is uh, quite difficult when it comes to understanding very accuracy or very specific area in the brain, because there's a noise problem, because it is not an invasive process. We put something over scalp, and that device which basically getting some signals from the brain and just trying to generalizing that what's happening in the brain. So instead of using actual EEG, we can move towards intracranial EEG, but it is invasive in process, that we need to just get into the brain to understand the specific area that is getting triggered or that is actually involved in epilepsy. So before we move ahead, we need to understand some characteristic when we talk about this EEG data. So one thing is that there's a temporal property of the data, because data is being observed for a longer period, or is it just broken, or has been used for shorter period. That is also very important, because when we trying to understand the case history of epileptic patient, so we need to actually figure out the how we can do longitudinal study. But as this data was publicly available, so it was quite difficult to do that. So now the second point is very important, that how that data was distributed, because we need to take data before the epilepsy, during the epilepsy, and after the epilepsy also. So that is practal, ictal, and interactal class distribution. Also, the main important part which is mentioned in this third point, which is like there has to be some personalized data set or modeling, so that we can understand individuality that is happening in the case of epilepsy. So there has to be some subjective personalized data or modeling formation. Some recommendation are mentioned there, that data, whatever data we are using, basically should be standardized. Like the data which was available for the study was very imbalanced, because as we have seen, the epilepsy case was less than 1% comparing to total data set. And so that is one point. Also, the patient and the type of seizures was taken in the study was very limited, so we need to focus upon more diversity of that, because patient can come from different background. So there is a variety of variety of culture, variety of places, and also the type of seizures, because they were already only focusing or taking seizures in a general manner, but they need to be more specific while considering the seizure disorder. The last point is basically balancing the data, which is very normal to understand, because when we are trying to get into this whole data set, and which is obviously publicly available and which is not so much standardized, so we need to make it more balanced by involving more cases of seizure. Future potential is very important here, because this whole study tried to focus something, and they actually got some finding which is very much I would say against from using a publicly unstandardized data set, because that have some issues. One is that there is no personalized data mentioned there. The data was very imbalanced, and the problem, obviously the method EEG itself is a problematic thing when we are trying to understand some specific part of the brain. So we can actually move to or include more methods, like there is ECG that can that where heart activity can be measured, and we have EMG, muscle activity can also be measured. While we are trying to understand brain activity, we can also try to figure out what's happening in heart and what's happening in the muscle contraction or blood flow. And the last point is that study should be can be done long term, like it could be used longitudinal method to understand the whole history of a patient, and that would be helping us to understand the before epilepsy, during epilepsy, and after epilepsy phases. And the last point is standardize, which is already being discussed, that how standardized we can make this data, that would define the accuracy also. Yeah, so this was the some key findings that I have taken from this paper. I hope you have liked it. Thank you.